Hi class. The purpose of this video is to explain the role of underground water, specifically in karst topography and then in geothermal features. We've been talking about water that runs in a defined channel, a stream, and how it has the ability to really reshape the landscape by removing sediment, transporting sediment, and depositing sediment. When we look at the erosional force of water in a defined stream bed, we talk about abrasion where it takes these tools like rocks and it's able to grind away at the stream bed and the tools. We looked at chemical weathering where it can dissolve certain kinds of elements and minerals in the rocks. And then we looked at the hydraulic action of water, just running water. When we look at underground water, this is water that is flowing under the surface, so subsurface water. What we're talking about more than mechanical kind of abrasion is more chemical weathering and the chemical breakdown of the rock. So we're going to look at that today. So the next slide here shows you the solubility of different elements like sodium and calcium, etc. What you can see here as illustrated by the image in your textbook is that certain elements like sodium and calcium are much more soluble than aluminum. So if all of these started with the same amount of the element, over time what would happen would be sodium and calcium would be dissolved in the water. So they would be part of the solution. When we look at the role of underground water, what's really a key factor here is the idea of dissolution. This is the removal of bedrock through the chemical action of water, because remember, it's the water running in a subsurface environment that's dissolving these minerals. So you can see from this image from your textbook, you have things like disappearing streams that go into the ground. You might have a sinkhole. You have this column over here, or the stalagmite or the stalactite. So basically what happens in this underground water is if you have a certain kind of rock, particularly limestone, and limestone is so effective with underground water because it's made out of calcium carbonate, and we just saw on the previous slide that calcium is one of the elements that's really soluble. So imagine that you have water that is in the subsurface all the way up to, let's say, like right here. As it moves across the planes, remember when rocks are formed, they have joints and they have different cracks in them. So this subsurface water is moving through this underground environment. As it goes, it's dissolving things like sodium and calcium. And so it's making these large caverns. So you can see here a cave. It's this cavernous hole. And basically what has happened is the first stage of this development was water in the subsurface dissolved this material and left this kind of cavern. Then the water level dropped. So maybe the water in the subsurface environment was up to here, but now it's much lower. When that water level drops, now we have access to this big, dry, somewhat dry cavern. So that's the first stage, the creation of the cavern. Then the next stage is more decorative. So water, as it kind of seeps down from the top layer into the subsurface, it's going to dissolve minerals as it goes. And when it gets to this giant open area, what happens is that those chemicals that were dissolved in the solution will precipitate out, and they will start to form stalactites and stalagmites. Collectively, these decorative features are called speleothems. And so you can imagine that the water is running from the ground, which is at the top of this image, and as it gets into the cavern, these minerals precipitate and they start to form basically drop by drop these stalactites. And then if they drip on the ground, they start to build up from the ground, stalagmites. Sometimes they connect, and this is a column. The way I remember the difference between stalactite and a stalagmite is I think of the letter T like this, and maybe I can show you like this. So to me this looks like the letter T, and this looks like the letter M. I know it isn't, but that's how I remember it. So Here are some pictures. So what do you think this one is? Hopefully you said stalactite. And what about this one? Hopefully you said stalagmite. And sometimes you have these beautiful columns that are created as the water seeps out into the cave and precipitates the minerals that it was carrying in solution. Here is a place that I like to go. It's in Belize. What you're looking at here, all of these rocks are limestone. So that tells you that most of Belize was underwater at some point when these rocks were forming. And basically, if you go to Belize, you can get into the water you're looking at, and you can inner tube down rivers that go in and out of caves. So it's pretty cool. So here's a picture of us tubing down the river, and you can see like here's a cave over here. Do you see how it looks a little like concaved here? Basically, that tells you that at some point the water level is much higher and has been dissolving this limestone. There are lots of caves in Belize, and here is just one of the caves. You can go down. It's pretty dark, and then it's me looking up at my husband and my son as we were exiting the cave. Another cool thing, and maybe if you've ever been to Mexico on the Yucatan Peninsula, you might have seen a cenote. Basically, a cenote is an underground cave whose roof has collapsed. So here's my son. He's going to go swimming in here. Lots of people were swimming in this cenote. A lot of people had snorkeling masks, and they could dive down right about here, and they could see deep in the water the entrance to the underground cave system. So these are some of the things that you would find in karst topography. So karst topography has been modified. The landforms have been created basically from limestone and with underground water. The other thing I wanted to talk to you about is hydrothermal features. And by the way, all this can be found in chapter 17 of your textbook. Hydrothermal features, hydro water, thermal heat. Basically, when we have an underground heat source like magma, like you see in the screen in front of you, it heats up the rocks, and if those rocks come in contact with water, then we have a geothermal feature, in this case like a hot spring. One of the places you can see a lot of this is in Yellowstone. You can see things like geysers and hot springs here, and so we're going to talk a little bit about that. Here is a picture of the hot springs you might find in Yellowstone. Basically, Yellowstone is sitting on top of a super stratovolcano, and while you won't see a lot of evidence of volcanic peaks on the surface, the magma is below the surface heating the water. The brilliant colors you see in this image are algae that form in these warm hot springs. Here's another one. They have such beautiful colors, truthfully. If you ever have a chance to go to Yellowstone, I highly recommend it. And if you do, take pictures and send them to me. Now, closer to home are hot springs in Mammoth near, the city of Mammoth in the Sierra Nevadas. And so here you can hike down. People get into the river you see right here. And parts of the river are warmer because of the hot springs. Why do you think there would be hot springs near Mammoth? Maybe you thought, well, there must be some kind of heat source underneath, and you would be correct. Mammoth is on the edge of a caldera. It was a super volcano, and the molten material is not too far from the surface. In fact, you can see a lot of evidence of volcanic activity in this area. When I was there last summer, a visitor was standing next to me on the overlook with his swim trunks on. He's like, oh, I'm going to go down to the hot springs, and he wanted to go into these brilliant blue pools. It would have scolded him, and I just said, you will get scalded, and it's too hot. My boys were a little embarrassed that I was giving advice to a stranger, but I felt that was my public service announcement. So if you go, just be very careful, because the water can go from feeling very enjoyable to hot enough to kill animals or even yourself. So just take caution. If you go to Yellowstone, you can see a geyser. So what happens with the geyser is the water fills up a chamber underground, and it gets superheated, but it's under a lot of pressure. And so until the top of this area kind of expands with the steam and can explode, it builds and builds and builds, and then all at once it erupts. And that's what you're seeing in these pictures right here is the eruption of Old Faithful. And here's a smaller geyser. If a geyser erupts pretty regularly, that just means that the heat source remains and the water kind of regularly fills the channel, which is what happens with Old Faithful. Another cool thing that you can see in Yellowstone are what are called travertine terraces up here by Mammoth Hot Springs, not to be confused with Mammoth Mountain in the Sierra Nevadas. So basically, this is what happens. We have moisture from the atmosphere percolating down into the rocks, and as it percolates down, it dissolves the minerals. Then we have magma. Magma has heat. Magma has gases that it gives off, specifically carbon dioxide. Well, when the water and the carbon dioxide interact, it makes a weak carbonic acid. And as that water flows, in this case kind of downslope, it starts to dissolve the minerals in the rock. And then when it exits, because it's flowing down and now it has access to the air again, the carbon dioxide dissipates, and what is formed are a rock called travertine. And they're brilliant white travertine terraces. Maybe you've heard of travertine. People use it for material on their floor in their bathrooms. You have to be careful because travertine is actually beautiful but kind of weak, and you can definitely ruin it if you use certain solvents on it. So these are the most remarkable hot water terraces in the world. So if you ever get a chance to go, definitely check it out. It's the calcium carbonate, like limestone, is precipitated out as travertine. So, well, I hope you found this informative, and let me know if you have any questions. Take care. Bye.